In this video something about problems with very small transformers. And I bought not too long ago these 3 transformers and also this one. And when we read on the type sheet we see that it can deliver, say, 12 volts at 62 milliampere, and here we see that it delivers 0.35 volt ampere. Of course, volt ampere is a kind of, say, tricky idea to indicate the power. That has everything to do with the properties of AC and DC. So for this video, and to keep it simple, we can say that volt ampere can be compared to watts, though that in fact only refers to DC in a certain way, because with AC we have to do with, say, the building up of the energy during the voltage rise to the positive, and the voltage goes back to the 0 and then to the negative. So, well, it's more complicated, but for this video I want to use that the idea that volt ampere is watts anyway. So we can also use Ohm's law, and that's a very good, say, first idea to get an idea about the power of, say, such transformers. Well, I've used here some, say, 6 volt and more bicycle lamps. I always use them, say, to test the output of a transformer. Of course, not always with bicycle lamps, but also with, say, automotive lamps that can handle 21 watt or 40 watt. And there are more videos on my YouTube channel where I have explained that. But in this case, because we are talking about transformers that only give out a very tiny amount of energy, I use these bicycle lamps to, say, get a kind of indication of what such a transformer here can give out in terms of energy. So, say, watts. When you have such a transformer like this, or another transformer that has 2 secondary outputs, here you see that 2 windings of each, say, 6 volts. When I have no, it's 2 windings of 12 volt each. So you can, say, get out of such a transformer 24 volts. And of course, important to tell, 24 volts is a nominal value. It is a value that is related to the current that is taken out of the transformer. In real, you will often, say, measure a higher voltage, but anyway, I was talking about the phase problems. Well, you see one winding and another winding, and here is the schematic, and the phase issue tells us that when you don't make the proper connections here, and when you want to take 24 volts out, or even 12 volts out. In a 12 volt situation you have to parallel both windings, and in a 24 volt situation you have to set these windings in series. When you do that not in the proper way, the wave on say 50 Hz or 60 Hz will extinguish out. It has everything to do with the phase, and that means that you say when you solder this together in a not proper way, you measure nothing. No output voltage and no 12 volt output voltage or no 24 volt output voltage. So be careful, do some tests, take your voltage meter, AC voltage meter, solder these windings in say a more or less random way. For instance, here a soldering, and then measure here the output voltage. Sometimes these transformers have say an indication where the secondary windings begin, say with a red dot or so. Anyway, that's the phase issue. And furthermore, the power issue, that's more important, at least in my opinion. Does such a transformer really give out its energy? And when we're going back to Ohm's law, that must be, in this case, for instance, 2 times 12 volts, so 24 volts. And in this case, say 0.35 watts. The power issue is, of course, very important. I have now soldered in a quite tiny main transformer, and the indications on that transformer tell us that it gives out 6 volt at 175 milliampere each. So for each of the windings of this secondary. So together that must be 12 volt at approximately 175 milliampere. And you can do some experiments and test with such a bicycle lamp whether that transformer gives out some real energy. And it's also a way to say find out the phase of such a transformer. So here, for instance, when the phase is not correct and you connect here a bicycle lamp, the lamp will not light up, or will light up in a somewhat weak way. And I've done say a few experiments, and this is the bicycle lamp at the moment connected to this transformer, and you can see that the lamp lights up in a very, very faint way. So that is the only energy that this transformer can give out. And of course, a better way to test that is to connect such a bicycle lamp directly to the windings of the secondary of that transformer. That gives a better indication. Here I have now at first connected a say DC rectifying circuit. You can see it here. And of course, during a certain time, the voltage that is, say, generated on the electrolytic capacitor, because this is a bridge rectifier, it's 1.4 times the AC voltage in a, say, not loaded situation. So we have here a quite high voltage, and when you connect without knowing that there is a quite high voltage here, you will see that lamp flash. Perhaps I can demonstrate it. It doesn't burn through, but the lamp doesn't, say, burn out. But there is a possibility that it really burns out when you do this experiment. So I hope this will succeed. So you saw the flash. It has everything to do with the property of the transformer. It is able to charge such a big capacitor. Here there is a big load inside, electric load, that discharges over this small bicycle lamp. But the more important thing is such a transformer able to give out a certain current during a certain time, during a day, a few days. So what is the, say, exact output current that such a transformer can give? And here these lamps can help. So test your transformer. You can measure it, you can measure the output voltage, you can measure the output current, of course, by, say, adding an AC meter, AC current meter here, and then with a certain load. Say you can use the this formula, Ohm's law, anyway. Could be criticized, but anyway. And here, when the voltage is rectified, you can surely use Ohm's law to see the real current that such a transformer can give. And perhaps you will be disappointed. A little bit like I was disappointed. I wanted to use these transformers for all kinds of purposes, say small pre-audio amps, but anyway, you don't have to be disappointed when you do the calculations. So, a good usable transformer for more powerful applications. Buy such a transformer to be absolutely sure that your electronic circuit gets the voltage and the current that is needed for that specific application. And furthermore, of course, in such a test procedure you can also use power resistors or these kinds of lamps, or say Christmas tree lamps. For instance, this is a Christmas tree lamp. So read on the Christmas tree lamp where it was made for, certain current, certain voltage, so you can apply that to your say test circuit. That was all to tell. I hope it was a little bit clear. Do some experiments, try and test, find out the real, say, voltage and current that such a mini transformer can give in a certain application.